Good morning to all. Today's topic is breakdown in vacuum. The idea of using vacuum as an insulator is very old, and the reasoning behind this idea is self evident. In the transport of electricity, it is depends on the transit of charged particles. Charged particles, as you know, electron, positive ion, etc. In the absence of any such particles, that is an absolute vacuum. But these particles are always present in small quantity. In the practice, however, the existence of metallic and insulating surface within the vacuum and the presence of absorbed gases and oil vapor complicate the issue, so that even in vacuum a sufficiently high applied voltage will cause a breakdown. A vacuum system which is used to create vacuum, the pressure is maintained at a value much below the atmospheric pressure. In vacuum system, the pressure is always measured in terms of millimeters of mercury, where one standard atmosphere is equal to 760 millimeters of mercury at a temperature of 0 degrees Celsius. These are the classification of vacuum system. We can say a high vacuum, and its range is 1 into 10 to the power minus 3 to 1 into 10 to the power minus 6 torr. Very high vacuum, 1 into 10 to the power 6 to 1 into 10 to the power minus 8 torr. And ultra high vacuum range is 1 into 10 to the power minus 6 torr and below. In a high vacuum, even if the electrons are separated by a few centimeter, an electron cross the gap without encountering any collision. Therefore, the current growth prior to breakdown cannot be due to the formation of electron avalanche. However, if a gas is liberated in the vacuum gap, then breakdown can occur in the manner as described by the Townsend process. Thus, the various breakdown mechanisms in high vacuum have established the way in which the liberated of gas can be brought about the vacuum gap. There are many different mechanisms for breakdown in vacuum have been proposed. These can be broadly divided into the three categories. First is particle exchange mechanism. Second is field emission mechanism, and third is clump theory. And particle exchange mechanism, we assume that a charged particles would be emitted from one electrode under the action of high electric field, and when it is attacked on the other electrode, it liberated oppositely charged particles These particles are accelerated by the applied voltage back to the first electrode, where they release more of the original types of particles. And when this process becomes cumulative, a chain reaction occurs which leads to the breakdown of the gap. In this process, a particle exchange mechanism involves electron, positive ion, photons, and the absorbed gases at the electrode surface. This is a picture for better understand. Second is field emission theory. In this theory, electron produces a small microprojection on the cathode due to the field emission bombard, the anode causing a local rise in temperature and release gases and vapor into the vacuum, and these electrons ionize the atom of the gas and produce positive ion. These positive ion arrive at a cathode which increase the primary electron emission due to the space charge formation and produce secondary electron by bombarding the surface. This process continues until a sufficient number of electrons are produced to give rise to a breakdown. This is the picture as you are seeing in the heating of microprojection on the cathode. Third is clump mechanism. Basically, this theory has been developed on the following assumptions. First, as loosely bounded particles exist on one of the electrode surface. Second, on the application of high voltage, the particles get charged. And third, the breakdown occurs due to the discharge in the vapor or gas released by the impact on the particle at a targeted electrode. These are three views of pictures which are showing clump loosely attached to the surface, as I am showing first picture. Second, clump is detached from the cathode surface and it accelerated across the gap. And third, impact on the clump on the anode gives out a cloud of metal vapor. Thank you.